Okay. So those of you that are over here, we're going to go over the math. Okay. So what I would like you to do is we only we have how many sections of math today? We just have one. Did we finish everything yesterday in this group? Okay. So what we're going to do is we're going to start on page number 78, question number 41. Is everybody with me? So what I want you to do is I want you to read the problem, see if you can figure out what it is. Give me a minute. I'm going to make sure they're on path, and then I'll be back to you. One person with the document. Okay. When you All right, so we're doing question 47, correct? 41, fantastic. I can't read. Okay, so 41. So on 41, it says a construction worker accidentally dropped a brick from a high scaffold. What is the velocity of the brick after 4 seconds? And how far does the brick fall during that time? Okay, so let's go ahead and plug that in. So he said we're going to do the velocity final formula, which is velocity initial plus average acceleration and time final. Okay, so we should have velocity initial, we should have acceleration and time final. Okay, so what is my velocity initial?
No, it'd be 0. Because he's dropping it from the scaffold, so.
Okay, so the velocity is 0 meters per second. Okay, what is my average acceleration? 9.8, which is gravity. Is it positive or negative? Okay, negative 9.8 meters per second squared, right? What is my time final? 4 seconds. Now, get your calculator. The first thing you want to do is you want to check to see what mode it's in, right? Because my honors class is using it in radian, and you got to have it in what mode?
Degree.
No, it's in degree, and it should be in radian. I said it backwards. It's my fault. So what we're going to do 0 meters per second, right? Plus negative 9.8 meters per second. And then we're going to multiply that by 4.0 seconds, right, guys? So let's see what we got.
So would you leave the square out? And
there's no, yeah, this is the thing. The meters per second squared is a unit, and I would just put it inside there.
So
yeah, that's why I changed that little bracket, because it made it look like you're supposed to, and I was trying to do it without you catching me, but you caught me anyway. All right, guys, what do we get?
I get 39.
39.2, right? Negative 39.2. If you did not get that, raise your hand and I'll come to you. Are you good, Robert? Put it in your calculator, make sure you get the answer. Does anybody have a question about that? That is A. How are we going to find B?
Use the final position formula,
Okay,
which is behind you. You already.
all right. So position final equals, we're going to say X initial plus velocity initial time final plus 1/2 of acceleration times time final squared. Right? That's what it says there. Okay, so let's see what we've got. Do we have initial? Do we have initial? Position.
No.
Yes, so if it doesn't say, what does that mean? It's 0, right? All right, so we have our initial position, which is 0, plus. All right, do we have our velocity final?
Velocity initial.
Excuse me, position initial, we got velocity initial, correct.
Yes. 0.
That's 0 too. Do we have to put that? No, because, okay. So time final,
4 seconds.
okay? 4.0 seconds plus 1/2 of acceleration, negative 9.8 meters per second. Time final squared. What's my time final?
4, or it'd be 16 because 4 squared is.
Okay? Plug that into your calculator and tell me what you get. So it's 0 plus 4.0 plus 1/2 times negative 9.8 in close bracket, open bracket 4.0 seconds. I think I have to put a 5 there. It is an S, correct, or is that a 5?
It's S.
Thank you. Squared. What do you get? No, it's okay. Let everybody.
I got negative 74.4.
Okay.
So if we were to do a position time graph, because the initial position is 0.
Yes, sir.
So it would be like it would go negative to 70.
I'm sorry. Say that one more time. I wasn't listening.
Can you draw a position graph?
Sure. So what would you like?
So you draw your position time graph, and then
Okay.
so your origin would be at 0, right?
Now, the first thing we want to ask ourselves, am I going to do this or am I going to do a T-graph instead?
T graph because you're going negative.
All right.
So because your position initial is at 0, B for the and then when you just go straight down to like at 4 seconds it'd be negative 74 meters.
Yeah. So is it going to go straight down the whole time or is it going to go up and then come down?
It'd be straight down because
What's happening to what it's asking? Straight down.
okay. That's
You good?
yeah, because the scaffold or wherever it was at, where it was hold on, it confused me because you would think it'd be up there and go down.
But he's at a 0 position though, right?
Yeah.
Now, the only way that would happen is if he was like 4 meters up. You know what I'm saying?
Yeah. If it
Then you
pulled
could,
us-
yeah. All right. Is everybody good with that question? Okay, let's go to the next one.
Miss Long, what was the answer to that one? Nobody never did it.
Can you say it one more time, sir, what your answer was that you got?
Or B.
Yep, for A.
A.
Yeah.
39.2.
I put negative 39, ma'am,
Okay,
on my paper.
all right.
Does that sound better? You
Yes,
good? Okay. Yep. All right, is everybody ready for the next one? Okay, so the next one is number 42. 42 says, suppose that the previous problem you've chose coordinate system, so the opposite direction is positive. What is the brick at 4 seconds? Everything would be positive. It's the same answers, except they would be positive. Yep, 39. I put a positive 39. And then on your B, what do you have? Right, there we go. Everybody good. That one, 42 is really easy. We're just doing the opposite. Are you ready for 43? A student drops a ball from a window at 3.5 meters above the sidewalk. How fast is it moving when it hits the sidewalk? So what are we looking for? Him hitting the sidewalk, right? The velocity final, right? Because that's where he ended up at. Velocity final, okay? And so what are we looking for?
The velocity initial. Oh, why would it be squared?
Okay, so why would it be squared? Do we want velocity final squared? We want velocity final, correct? How do we change that from that to velocity only? Square root
Oh.
of the formula. It's okay. It's after lunch. Okay, so what do we have? What do we have as far as the variables in our question?
We have the positions.
Okay, so the thing we got is position, right? That's 3.5 meters, right? Do we have anything else?
I guess acceleration. But wouldn't that be 9.8?
So our acceleration would equal gravity, right? Which would be 9.81 meters per second squared, correct? Now, do we have a velocity initial?
No.
We don't, do we? So we're going to take, so we're not needing this, do we? This is all we need, isn't it? Does everybody agree? Do you understand why I'm square rooting it though? Because I'm just looking for a velocity final. So it's 2 times 9.81 meters per second squared times what?
3.5.
3.5 meters, okay?
Would it not be a negative 9.8 since we don't have them?
Okay, let's put it in our calculator and see what we get. You square root it, Robert? You square root the whole thing? I gotta take that negative off. Negative won't work on square root, and I know that. Hate that. Because when the negative in the square root makes it positive, guys.
Yeah,
God bless. What'd y'all get?
8.28.
8.28673639. Is that the number you got in your calculator?
I didn't get the 6, 7. Yeah. Past that.
Okay, so did you do 2 open, did you square root? 2 open bracket 9.81 close bracket 3.5. Let me check my mode. My mode's in degrees. It's Miss Sloan. Yeah, I'm preaching to y'all and I can't even do my own work. Still didn't, it didn't change. It didn't change it. Yeah, it's going on radiant. Let me see what you got. Because you said you got a different answer than me. I need a different answer than you.
Did you square your
Did not square.
I didn't either. I did.
The only thing I didn't do is put my bracket around it. I don't think it makes that big a difference.
I don't think so. That's what I'm gonna.
Okay. Okay, you squared that, don't square that 9.8. I don't know if that bracket makes that big a difference. So look at mine and look at yours. I have the exact same thing as yours.
But 8.1, I just did 9.8. So I just did differently.
Okay, cool.
5.
Well, we got it.
Yeah.
Okay.
Okay.
I was like, why are you getting a different answer? So what is my answer?
8.3.
8.3. What's my units?
per second.
Because I'm looking for velocity.
Would it be square?
It would, meters per second squared. No, it would just be, yes, it would be meters per second squared. How you feel so far? Feeling better? All right, go ahead and do the next one, please. All right, so it says a student drops a ball. Is that the one we're at? Okay, I'm sorry. Oh, a tennis ball is thrown straight up. Okay, with initial speed of 22.5 meters per second, it's caught in the same distance above the ground. How high does the ball raise?
The final position.
Right? 8. It's an X, right?
Yes, ma'am.
F.
So I guess the. This little.
Yes.
Yeah, I think the initial position, would that be 0? I guess so. It doesn't tell us, so it would be. Huh? Yes.
And so is you don't have to have that consistent. He's still using it.
Final.
That's all we do.
Paperwork. 0.
Got it? Or are you typing it in and she's doing, I don't care which one you do, but one person should have the screen on for the free fall, the other person should have the document.
Right. She did I think I did the wrong. Yeah, I did. I did the wrong formula.
Okay, so is he telling you what you're supposed to be doing here? I didn't hear that conversation back. So, be all good. So, you know, I need somebody to please go up and do the problem while I'm up in the back here. I don't hear it is.
The thing is though.
Dave, what's your last name?
Good wrong.
I, Mr. Gogram.
Okay, reason that formula, so. Let's see, that. The initial position would be 0. This is going on YouTube as well.
Oh.
And then you'd, add the velocity initial, which is 22.5 meters per second. And then you times the time final, which we don't know, so I don't know how you're supposed to do that, but
I tell me what you're.
And add,
Tracy, you guys, just get out there and make your copy. So if you pull down underneath the file, you'll see make a copy,
second,
right, baby?
they still know what the time final is.
It says copy of a copy or whatever, put your name
That's
on
the
it. and
formula I
send it on to the
used. And then here's the
Do your-
calculator. Okay.
job.
Miss Lum, so what do we do if it doesn't give us the time final?
Okay, so what's happening to the ball?
So we're trying to find the final position, or, yeah, the final position. So we use this formula.
Okay,
It gave the initial position would be 0 because we're starting from the ground.
right,
And then it gave us the initial velocity, which is 22.5 meters per second.
okay,
And then we have the final time again. And then plus 1/2, the acceleration, which is 9.8.
uh-huh.
And then times that by the
Final
time
squared.
Yeah.
So what is it, does it even tell us how long it was doing it?
Here. It doesn't give us a time. It just gives us the velocity initial.
So can we solve that problem?
I don't think so.
Okay, not using that formula,
No, probably not.
okay?
So what
So,
formula would you use?
We need to find guys in this group, y'all are working together. He just decided he doesn't have all the information. He cannot find it using that formula. Okay, y'all need to find another formula that has the variables. But can we start first with listing the variables first,
Mhm.
what you're looking for, and find a formula that you can do it with, please, sir?
Sure.
Sounds great.
Okay, so the x initial 0, the velocity initial is 22.5 second. The acceleration. Okay, that's what we know. What formulas can we use? Use that. Okay, you guys help me out here. Yeah. Mhm. Some yesterday's notes. We could do this formula, so x final equals x initial plus final velocity squared minus final initial squared divided by acceleration times 2.
Let's go.
I got rid of it. So. Well, do we know what? No, yeah, we do, because it would be 0.
There you go.
So we plug this in. It'd be
Yep.
0
0 plus.
0 squared, which is 0.
Well, can we just go ahead and say 22.5?
Yeah, we could.
Okay,
because-
instead of doing the 0?
Well, it would be negative 22.5.
Exactly. So go ahead and put it up there.
So negative 22.5 meters per second.
Over 2 times 9.8.
Yeah, it would be positive
81, please. Meters per second squared.
squared.
All right. Are you good, or you want me to finish it, or you're still rolling?
I'm gonna plug it in.
All right, let him roll, because he's doing great.
0 plus y equals negative 22.
Now, boys over here and girls, do you understand what he just did? He went in, we wrote down all the variables that we had. He looked in his little ISM book and he found the equation that would fit.
And we're looking for position, final position, so it just
Be
be
meters. So the answer is 26.3 meters.
Mhm.
Thank you, sir.
Yeah.
That was beautiful.
Right.
So just take over.
You know. All right, we ready for the next one? How long did the ball remain in the air?
So we
How long did it stay in the air?
find final range. I don't know what the final time formula is.
Okay, so what would make sense to you? We have the initial position, we have the final position, we have acceleration. And so can we find out what the final time is?
Well, if we figure out how long it takes for it to reach the velocity of 0, that's a hoax.
Okay, so I know, no matter what position it is, gravity is 9.81 meters per second. Meters per second
Not squared.
squared. Okay? So what else are we gonna do here?
Then we have to add the acceleration, which was 20. Was it? Yeah, 22.5,
Is our acceleration.
and then that gives.
Changing our position.
Change in position, that'd be X, or that, yeah. So if we,
So we have acceleration, right? Due to gravity. We have this one, which is 22.5. We have the change in position is 26.3. How can we figure out the change in time?
I think if we multiply the acceleration times gravity. and then
Okay,
use the-
hold on. So you're thinking we do acceleration times gravity. What else we gonna do?
And
Where are we gonna put position?
guess would you divide it by position? 26.3.
Okay, let's see what we got. And that's the thing, we gotta make sure that you are plugging it in a calculator, right?
So I would have gotten 8.4 seconds. And then you would times that by 2 to find.
I got 16.7.
Okay. Would that tell us?
That would tell us how
Pretty
much-
close. The best of our ability, right?
I guess.
I mean, I think you come up with a great plan. I've never thought of it that way, but that sounds like an awesome plan. Just threw formulas together until we get an answer, right? Okay. So what I'm going to do first before you leave this group, because we're going to be leaving in a minute, I need to give you back your tests. Okay. Now,
Okay, 0. That's 0.
I'm going to give this to you so you can look at it really quick. Excuse me. And then I'm going to take it back from you. I have a grade on it. I mean, I have to put it in a grade on it.
79.3. 79.
You,
Oh,
Sir?
97.
sir, you need to do, you have a chance of doing one test correction. And Bailey, you have time to do one, you have time, you have to do a test correction. That's yours. Yeah, do your test correction. Okay? Those of you that have gotten your test back and you have a grade, take a picture of it and attach it to where the grade is, where the assignment is for test. Okay? And then you're gonna turn that into,
I did that.
those of you that are doing test corrections, you're doing test corrections. And Claire, let me see if I graded yours yet, because I think yours is on the stack. So if you'll give me a minute, it'll be just a second so you can have test corrections, okay?
Haley, I'm going to be sending you, the numbers that you have wrong. I have printed off your tests for you and everybody else that's online. And I will be sending those pictures back with the lines on it so you can have one more chance of test correction.
All
All
right.
right, babe? And as far as I see, I think we're done for the day, so you can get off.
All right.
Thank you very much. I appreciate it, guys.